Today, we will be talking to you about Moore's Law, presented by our group Supra Smash Brothers, Estuardo Bustamante, Alexander Chen, and Anil Sohani. Our topic today is the power consumption of computer nodes doubles every 18 months. Moore's Law. We will be discussing what is Moore's Law, who founded Moore's Law. We will explain what are transistors, the pros and cons of Moore's Law, the reasons for the law, and examples of the law in action. So, let's get started. What is Moore's Law? Moore's Law predicts that the number of transistors and resistors on an integrated circuit chip doubles every 18 months. Transistors are devices that control the movement of electrons and consequently electricity. They start and stop the flow of current, and they also control the amount of current. This means that ever since the first microprocessor chip was introduced in 1959, the number of components on a chip with the smallest manufacturing costs per component, which are transistors, had doubled each year, and the trend may continue into the future. This law was later interpreted in different ways. There are at least 3 variations of Moore's Law. Number 1. The power of microprocessors doubles every 18 months. Number 2. Computing power doubles every 18 months. And number 3. The price of computing falls by half every 18 months. Who is the founder of Moore's Law? The founder of Moore's Law is Gordon Moore. He earned his bachelor in chemistry from the University of California at Berkeley in 1950. He also received a PhD in chemistry and physics from the California Institute of Technology in 1954. His rule became the guiding principle for the industry to deliver more powerful semiconductor chips at a decrease in cost. In 1965, Intel co-founder Gordon Moore founded Moore's Law. After it predicted that the microchip would double every year, he updated his prediction to once every 2 years. Moore's Law continued. The figure shows the relationship between the number of transistors on a microprocessor and millions of instructions per second, also known as MIPS, a common measure of processor power. The figure also shows the reduction of cost of transistors and increase in computing power. The more transistors on a semiconductor means more power and better performance. Through nanotechnology, chip manufacturers can reduce the size of transistors to the width of several atoms. Nanotechnology uses individuals, atoms, and molecules to create computer chips and other devices that are thousands of times smaller than current technologies permits. Many digital devices are linked to Moore's Law, which includes processing speed, memory capacity, and sensors.
The pros and cons of Moore's Law. A good thing about Moore's Law is that it matters to us more than ever before. It matters because the transition to cloud computing. Extra transistors gained through Moore's Law can be used to make the whole system better in the domains of security, lower latency, and higher performance within the cloud environment. It also addresses the proceeds different elements. Moore's Law is relevant because it opens up the huge percentage of applications not available with the current cloud structure. The improvements in chip and diverse computing will make it possible to run applications universal to any enterprise, giving businesses cost-effective benefits, flexibility, and scalability that are possible with the cloud. A con is that physicist Michio Kaku says Moore's law will hold true for only 10 more years. Kaku says, we're reaching the physical limits of silicon technology, and at a certain point, computing power won't improve at the rate we came to expect. Every few years, it may seem like technology reached the limits of what's physically possible. Reasons for the law. This law holds up because of the nature of humans. It is through mental factors that drives the market. Companies are always competing against each other to stay on top of the market. If a company does not outperform other companies or itself, its competitors will surpass them. Apple would be an example of a competing market who strives to outperform itself and its competitors to stay on top of the market. Since tech companies want to maintain their superior edge against their competitors, they make sure to be on top of their research and development, or better known as R&D. With the influence of R&D, companies can work to achieve newer and better techniques in order to create smaller components. As soon as the components are designed and physically built, the companies can then proceed in arranging the components to effectively maximizing the performance levels. In order to sustain a powerful research and development sector, a company must spend a lot more than it would to develop a product by itself. But the cost of R&D offsets the threats of the company's competitors against momentum and advancing in the market. As each year goes by, electronics get faster and much more advanced than the years before. Thanks to Moore's law, consumers expect newer and better technology produced year after year.
Examples of Moore's law in action. An example of Moore's law is the Intel's processor. As years pass by, the number of transistors increase in Intel's processors. And technology is always increasing from the Intel Pentium 4 processor around the year 2000 to the Intel Itanium processor, then the Intel Itanium 2 processor, and ultimately the dual-core Intel Itanium 2 processor. As the years go on, the processors increase in power, capability, and speed. Another example on Moore's law is decreasing costs. Over time, a computer that costs $1,500 today will be worth half the amount next year, and around 2 years, it will almost be obsolete. Conclusion. To wrap up, by now you should know what Moore's law is exactly, who founded Moore's law, the pros and cons of Moore's law, the reasons for the existence of the law, and finally, some examples of the law. Thank you for tuning in. This has been a Supra Smash Bros. Presentation, and these are our citations.